Okay, here's what question 4 of this exercise says. The houses of a row are numbered consecutively from 1 to 49. So there are 49 houses in a row numbered from 1 to 49. Show that there is a value of x such that the sum of the numbers of the houses preceding the house numbered x is equal to the sum of the numbers of the houses following it, and find this value of x. So there's also a hint given. We'll come to the hint later, but let me first show you a visual that will help you understand this problem better and how to solve it. So look at this figure of boxes, which each box represents a house. So this is the box on the left is the first house. Let's number it as 1. Then we have number 2. Then we have number 3. And then the last 3 houses will be 47, 48 and 49. Now this colored box is a house which is numbered x, and what the problem says is that the sum of the house numbers before this house should be equal to the sum of the house numbers after this house. So if you take all the houses before this house numbered x and add their house numbers, so these houses will go from 1 up to x minus 1. And then if we take all the houses after x, so starting here and go up to the last house, so if we start from x plus 1 and go up to the last house, which is number 49, and if we take their sum, so these two sums should be equal. So we have to show that there will exist such a house, there will exist such a number x, and we have to find that number. Now, looking at this visual, the way forward is actually quite clear. So what you want is that the sum of these house numbers from 1 to x minus 1 should be equal to the sum of these house numbers from x plus 1 up to 49. Now, the sum of the house numbers from 1 to x minus 1 we can write as x minus 1. So basically we use the notation Sn to represent the sum of the first n terms of an arithmetic progression. So Sx minus 1 represents the sum of the house numbers from 1 to x minus 1. By the way, I'm using S because the house numbers form an arithmetic progression. So we have the house numbers as 1, 2, 3 going up to 49. So this is an arithmetic progression of 49 terms with the first term as 1 and the common difference as 1. So Sx minus 1 represents the sum up to house number x minus 1. This should be equal to the sum from x plus 1 up to 49. Now here comes the interesting part. How do we write this sum? How do we write the sum from x plus 1 to 49? So to do that, what we do is we take the entire sum from 1 to 49, and from this sum we subtract the sum from 1 to x. So follow me again carefully. So what we do is that to find the sum from x plus 1, this house, up to this house 49, what we do is we take the total sum from 1 to 49, and from that sum we subtract the sum up to x. So let me highlight this. So we take the total sum from 1 to 49, and from this sum we subtract the sum from 1 to x. So what will we be left with? We'll be left with the sum from x plus 1 up to 49. So this is the logic that we use in this equation, in this question. So the sum after house number x we can write as S49, the total sum up to 49, minus Sx, the sum up to house number x. And then what we want is we want these two to be equal. We want the sum up to x minus 1 to be equal to the sum after x, which is S49 minus Sx. And once we have figured out this logic, the remaining part of the question is very simple. We just need to simplify this, and then we need to find the value of x. Now what we can do is, because this arithmetic progression is actually the sequence of natural numbers starting from 1, so we can use the formula that the sum of n terms, the first n terms, is n into n plus 1 by 2. So for the progression 1, 2, 3, this sequence of natural numbers, the sum of the first n natural numbers is n into n plus 1 by 2. So let's use this fact here. So S of x minus 1 will be x minus 1 times x minus 1 plus 1, which is x by 2, and this will be equal to S49 minus Sx. So S49 will be 49 into 50 by 2 and minus Sx. Sx will be x into x plus 1 by 2. So this is the equation that we get in x. Now what we will do is we will expand this product. So this will be x square by 2 minus x by 2, and we will bring this product to the left side and expand it. So this will be plus x square by 2 plus x by 2. So this is what we will get from this term here, and on the right side we will be left with this term 49 into 50 by 2, or 49 into 25. Alright, now what are we left with? So this x by 2 terms cancel out, so we are left with x square by 2 plus x square by 2, which is actually simply x square. So x square is equal to 49 into 25, and we can see that 49 into 25 is actually a perfect square. It is the perfect square of 7 into 5. So x square is 7 into 5 whole square, and this means that x is equal to 7 into 5, or 35. So here's our answer now. This house number that we were looking for is house number 35, and the sum of all the house numbers before 35, which means that the sum of house number 1 up to 34 is equal to the sum of house numbers after 35, which means from 36 up to 49. So as a verification of this question, you can actually verify that the sum starting from 1 and going up to 34, and the sum starting after 35, which is 36, and going up to 49, these two sums will be equal, exactly equal. So you can verify this as an exercise, follow-up exercise to this question. So the answer is that the value of x is 35. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.